In day 8, we're going to talk about the square root family and also reflections. Warm up. Explain in words how the function y equals x minus 7 squared minus 19 shifts from the parent function y equals x squared. So if you recall, we've talked about the h and k values for shifting the graph, and if it's inside the parentheses, that is the left or right shift, and it's always the opposite of what you think. So again, the only thing inside the parentheses is the x and the left or right shift. So the minus 7 is actually a shift to the right. So this is right 7 units from the parent function. And then it is a quadratic as indicated by the square, so we do know that it curves up, this shape right here. But the minus 19 on the outside of the parentheses, that's your up or down shift. And if it's negative, that means it goes down 19. So when I ask you a question like this, again, I'm asking for in words. I'm looking for what direction does it go. And so this parabola would shift right 7 and down 19 from the parent function y equals x squared. So our goal today, again, is to take a look at this new parent function, the square root family, and then to take a look at how do we reflect graphs. So for part 1, what happens if there's a negative on the outside of the parentheses? And to figure out what happens, what we're going to do is we're going to use Desmos. So we're going to start with our parent function that we used yesterday, which is the quadratic, the x squared function. So if you forgot what it looks like, go to Desmos and type in f1 of x equals x squared. f1 of x just means like our first graph, and that's all the little subscript right here means. So I'm going to go to Desmos. All right, so graphing calculator. And if we type in f1 of x, again, all that means is our first graph, f1 of x, first graph, parent function. And I'm just going to type in x squared. So I hit the keyboard to get the squared button right here. And there we see the parabola that we have studied in the previous section. We see that the origin is at 0, 0. So then it says type in f2 of x equals negative x squared. So what happens if that negative is on the outside of the parentheses? All right, so we're going to type in f2 of x. It just means our second function. And we wanted it to be negative x squared. Okay, what happens to our graph? So the blue graph is our new function. It says sketch and label them on the coordinate grid to the right. What do you notice about these graphs? Okay, so my first graph was red. So if I graph this function, looks something like this. Okay, and that was our f1 of x, which is our x squared, our parent function. And then we graphed our second one, f2 of x, and it looks something like this. So this was our f2 of x, which is our negative x squared. Oh, we had parentheses as well. Let me rewrite this so we can see it better. All right, so f2 of x is negative x squared. Okay, so describe in words what happened to the blue function from the red function, and we could say something like it flips over the x-axis. We can say it's upside down. So negative x squared is upside down. We can say it flips over the x-axis. So write down anything else you might notice about our graphs here. Okay, so then part 2, it says clear the previous graphs. Type in the new parent function. So today we're going to focus on square root functions, the square root of x. And it says sketch the function on the coordinate grid. Why are there no x squared values? Okay, so I'm going to go back to Desmos. I'm just going to clear out the equations that I had, if I can find them. Here we go. So I'm just going to close these out. I'm going to type in our new parent function, f1 of x. So f1 x. I don't want 0. Okay, equals the square root of x. So let's look for the square root button. Oh, it's right here. So if you hit the keyboard, it is 3 below the x squared button. So there's the square root of x. And there's our parent function here. And if you notice, it starts at 0, 0, and it slowly increases. All right, so let's sketch that right here. And I'm actually going to make a table so you can see what the values are. So I'm just going to make a table, x, y. Okay, so if x is 0, the square root of 0, if we plug that in to our function right here, the square root of 0 is 0. How about the square root of 1? So if I plug in a 1, the square root of 1 is 1. The square root of 2 is a decimal. How about the square root of 4? We can do that. So if x is 4, we plug in the square root of 4, and that's 2. How about 9? The square root of 9 is 3, and that's how we're getting our function. So 4, 2, and then 9, 3 doesn't show. Okay. All right, so there's our function right there. It says, why are there no negative x values? So again, we see no graph over here where the x values are negative. And think about how I got these numbers in the table. I square rooted everything. So the reason why there's no negative numbers is what happens if you try to take the square root of -1, like if x was -1. And if you do that in your calculator, you get an error. And the reason is if we have, I'll do an example here. If we take the square root of 9, we get 3, because 3 times 3 is 9. If we take the square root of 4, we get 2, because 2 times 2 is 4. Now, if we have a square root of a negative number, you're trying to think what number times itself is -1, and that doesn't work. Or example here, -4, what number times itself is -4? And there's no number times itself that's a negative, because a negative times a negative is a positive, and a positive times a positive is positive. And again, when you square something, it's a number times itself. So the reason why there's no negative numbers here is no number squared is negative. So we don't see any part of the graph there. So I'll try to write that down here. Okay, so it says, why are there no negative x values? Because no number squared or times itself is negative. All right, so domain and range. Domain is all possible x values. So here is our leftmost point at 0, and then it keeps going all the way to the right. So for our domain, the x values, we say x is greater than or equal to 0. It's everything 0 and bigger. Let's look at our range. Range is low to high. Again, our lowest value is 0, and it keeps increasing. It keeps going up forever slowly, but it does keep going up. So our range here, we say y is greater than or equal to 0 as well. Okay, so now we get to the new part. So this is our parent function, the square root of x. It starts at 0, 0. It slowly increases. All right, what happens if we have a negative on the outside of the square root sign? So the square root sign is kind of like parentheses, like in the last problem. So again, the negative's on the outside of that. Let's sketch or type in both of these and see what happens. You can make a prediction what happens when we had a negative on the outside of this graph. Make a prediction what happens when we put a negative on the outside of this graph. And then we're going to go ahead and type that in. So I'll call my second graph f2 of x, just means my second graph. Let's put that negative on the outside. And I actually don't need, you can put parentheses, you don't need it with the square root, so here it is. And if you made the prediction that it's upside down, that it is a mirror image, it flips over the x-axis, you would be correct. All right, so let's write that down. So here is our reflection. Okay, so right here, how would you explain what happens to a function with a negative on the outside? So it's upside down, you might want to say. Upside down. It's reflection over the x-axis, you could say. So it flips over the x-axis. Okay, so that leads us to our first definition today. A vertical reflection is a transformation that flips a graph over a line, creating a mirror image. So we saw that today with our vertical reflections. It flipped over the x-axis and created that mirror image. So it says, given any graph, y equals f of x, so any function, the graph of negative f of x, so the negative is on the outside, is a vertical reflection across the x-axis. So vertical means it flips up and down, right? One's up, one's down. And then over the x-axis, we see that in our first two cases. Okay, So part 3, I think we have 4 parts today and then some practice. So part 3 is what happens if there's a negative on the inside of the parentheses or on the inside of the square root sign. So it says clear your graph page. Again, we'll keep in our original parent function today, the square root of x. But what happens if the negative's on the inside? Make a prediction. Okay, so, and I keep pressing the wrong one. All right, so I'm going to get rid of this one. And this time I'll call my f2 of x the square root, and I'll put the negative on the inside. Okay, ooh, look what happens. It's a reflection, but this time it's over the y-axis. Okay, so let's draw that. I'll draw my original function in red. Okay, so here is our parent function. Okay, but what happens if there's a negative on the inside and it went this, oops, not a straight line. Let me see if I can sketch this one better. It does curve. All right, so this is f2 of x equals the square root of negative x. Okay, so it says, how would you explain what happens to a function if there's a negative on the inside of the square root sign? This time it reflected over the y-axis. The y-axis being this straight up and down line right here. Okay, test your prediction. Clear your graph page. This time, type in this function. Okay, so this is a parabola. You see that square there? This is a parabola that shifts to the right 3 and up 2. Okay, so let's see if my prediction's right. It's going to be a U-shaped graph, and it's shifted right 3 up 2. Okay, so we're going to clear this. Okay, so this time I'm going to call my f1 of x. f1 of x equals, and it was parentheses, x minus 3 squared plus 2. Okay, and take a look. It did shift right 3 up 2. Okay, but now what happens if you put a negative on the inside of the parentheses? So you see this negative right here. First, I should actually graph this. So let's do this. Let's graph it. Right 3 up 2. Here was our new parabola. Okay, but now what happens if there's a negative on the inside of the parentheses? So let's type that in and see what happens. Okay, so we have f2 of x equals parentheses, oops, not that way. There's 2 parentheses. Here's the negative x inside the parentheses, and then the minus 3, and then it was squared plus 2. And again, notice it does reflect over the y-axis right here. So it's a reflection over the y-axis. So let's sketch that. I used opposite colors. Whoops. That's fine. All right, so this one, it reflects. What that means is it's the same distance. Each point is the same distance from our mirror line. So for example, like this point right here, if it's 3 away this way, we're going to go 3 away this way. And then we're going to sketch our graph. So there is the new graph that's reflected across the y-axis. So number 4, how would you explain what happens to a function if there's a negative on the inside of the square root sign or inside of the parentheses? And we would say it's a reflection over the y-axis. And so the name for this is it's a horizontal reflection. So horizontal goes left and right. And it says given any function y equals f of x, the graph of y equals f of, and in the parentheses, the negative x, is a horizontal reflection across the y-axis. All right, so let's talk about how we would sketch these out. And then you'll be able to try this for your assignment. All right, so let's say we have our original function, again, the square root of x. So if we graph that, it starts at 0, 0, and it slowly increases. The square root of 4 is 2, so 1, 2, 3, 4, 1, 2. So here it is slowly increasing. There's our original function, the square root of x. All right, what happens if there's a negative on the outside? So the negative on the outside is our vertical reflection over the x-axis. So it's going to go this way. So here's negative square root of x. And how I remember that it goes over the x, or it's like upside down, is x comes before y, and the negative on the outside comes before the negative on the inside. So I remember that's a flip over the x-axis. All right, let's go over the next one, f3 of x. What happens if there's a negative on the inside of the parentheses? So inside comes second, so it flips over the y-axis. So we take a look at our parent function, the one in blue, and we're just going to go this way. So here's negative, square root of negative x. So the negative on the inside reflects over the y-axis. What happens if you reflect it over the x and the y? Okay, so this is what this means. I'll try to get my colors here. So this means reflect over the x-axis, but then on the inside, it's reflect over the y-axis. All right, so think about reflecting over the x. Okay, so that would be this graph first, and then we're going to reflect this graph over the y. So this final graph looks like this right here. So this is negative square root of negative x. So reflect over the x, reflect over the y. I'm trying to point here, but it's not going to work. All right, so reflect over the x, reflect over the y, and then you end up with this graph that is kitty corner from the original. So again, here's the original in blue right here. And then when you reflect over both, it flips it this way right here. Okay, let's try it one more time with a new function, g of x. Okay, so let's call this funny looking symbol right here. This is now our parent function. So they don't always start in the first quadrant. Let's say g of x starts here, and that's our parent function. Okay, so this is our parent function, g of x. Let's do negative g of x first. All right, so remember the negative on the outside, it reflects. Sorry, this is messy. I'm going to rewrite this. So this reflects over the x-axis. All right, so reflection over the x-axis. What I'm going to do, and here's the x-axis right here, I'm just going to take each point. All right, so here are my 4 points right here, and I'm going to move them the same distance across the x-axis, so I'm just going to reflect it over. So like here's, this is 1 unit away from the x-axis, so I'll do it 1 the other way. This one is 2 units this way, so I'm going to go 2 units that way, and graph that right here. This is 1 unit away, so we're going to go 1 unit this way. And then this right here is 2 units away, so we're going to go 2 units this way. So again, all I'm doing is redrawing my points each the same distance away from the x-axis, and here's negative g of x. All right, let's do when the parentheses is on the, or sorry, the negative's on the inside of the parentheses. This is a reflection over the y-axis. So again, start with the original function, the blue. And this time we're going to go this way over the y-axis. So again, same thing, mirror image. So this first dot is 1 away, so we're going to do 1 away again from the y-axis. Our second dot is, this dot's 2 away, so we're going to go 1, 2, 1, 2, this way right here. This one is 3 away, 1, 2, 3 away. Oops, I erased my dot here. And this one right here is 4 away, so we're going to go 4 away. And here is our new function. Delete all my extra stuff here. Okay, so that is negative, no, g of negative x. So when the negative's on the inside. And our last one is a reflection over both. And you can actually go over the x over the y or over the y over the x. Doesn't matter the order, you'll get in the same spot. So this is a reflection over both of those axes. So I'm just going to take my purple one, which is over the x, and then reflect it over the y. So I'm reflecting it over this line. 1, 2, 3, 1, 2, 3, 4, 1, 2, 3, 4. And so there is our final graph, negative g of negative x. All right, so 2 main ideas from today's lesson. The first is a new parent function, the square root of x. So the square root of x looks like this purple graph right here. It starts at 0, 0, and it slowly increases. If you make a table, here are the first few values, 0, 0, 1, 1, 4, 2, and that's how they get that graph. So you need to know the shape of a square root function, the green one, green/purple. And then the second thing is you have to know how a negative affects how the graph reflects. So again, if it's on the inside of the parentheses or square root, it's over the y. I should do over the x first. All right, so if it's on the outside of the parentheses right here, it's over the x, which is this way. If it's on the inside of the parentheses, it's over the y value, so this way. And then you could have both of them where it reflects over the x and over the y. So in your assignment today, you will practice looking at these graphs, coming up with the equations, but also drawing them. So that'll be your goal today, is to finish the day 8 daily practice.